Happy day students. So today is day 8 in which we are studying waves. In the last class we studied about standing waves. There are certain basics that I gave you about standing waves. Further more basics we are going to clear with the numericals and the further information that I am going to give you right now. So in the last class we found out the wave equation was something like this: 2a sine of kx cos omega t. Okay, now this wave equation was found by interference of two waves which were of same amplitude and frequency and both were moving in opposite direction. That means if the question asks us find out the constituent waves of this standing wave, then we should be able to find out that also. Now we know that y equal to y1 plus y2 we did in our last class. What was y1 and what was y2, that I am writing. It was a sine of kx plus omega t plus a sine of kx minus omega t. Okay, that means kx plus omega t and kx minus omega t. Okay, these are its constituent waves. Same way, a standing wave can also be written like this. It can be 2a cos kx sine omega. This is also a standing wave. Okay, if suppose this standing wave is given and it is asked from us write its constituent waves, then what we will be writing? Again, this will be a sine of kx plus omega t minus a sine of kx minus omega t. Okay, this will be the constituent waves for this equation. Same way there can be third form of also for the same standing wave. What it can be? It can be 2a cos kx cos omega t also. Okay, so what is the constituent waves for this one? It will be a cos kx plus omega t plus cos kx minus omega t. Okay, then another one what we can have? Another one is both are sine form. Okay, sine kx sine omega t. So see what will come in that. Y equal to 2a sine kx sine omega t. Then that one what we will be writing? The constituent waves will be a cos kx plus omega t minus a cos kx minus omega t. Okay, so these kinds of questions also asked in the competitive exams, so we should be able to find out those. Okay, so four types of standing waves I have written: 2a sine kx cos omega t, 2a cos kx sine omega t, 2a cos kx cos omega t, 2a sine x sine omega t. Okay, all these are standing wave forms. So if any one of these is given to you, you should not be getting confused. These are all standing waves. Okay. Now let's go back to the standard equation that we got, that is 2a sine kx cos omega. Okay, now in this one we will try to find the positions of nodes and antinodes. As yesterday in the last class I told you that there are certain points which have displacement 0. Okay, all the time the displacement is 0. And from those points energy do not transfer from one loop to the other loop are called nodes. Okay, so if suppose this is the wave equation given to us, how to find the position of nodes on the string? And in the last class also I told you that this here represents the amplitude of standing wave. Okay, so if we talk about node means what is the value of amplitude? Amplitude is 0. Node means 0 amplitude. That means this value is 0. We'll say 2a sine kx is 0. Now we know that 2a, this a can't be 0 because a actually is the amplitude of the traveling wave which interfere and give us standing wave. So a can't be 0, 2 can't be 0. That means the sine kx definitely is 0 then. Okay. Now sine kx is 0. So this kx value is what then? Now kx value is either 0, or it can be pi, or it can be 2 pi, or it can be 3 pi, and likewise. Okay, so that means x value, the position of node for this particular wave, can be 0. Then second one, this k value is 2 pi by lambda into x1 equal to pi. So second node value is lambda by 2. Same way third one we can see for this one, 2 pi by lambda into x equal to 2 pi. So where is third node? Third node is at lambda. Fourth one, same way for 3 pi, you can say 2 pi by lambda into x3 equal to 3 pi. Pi gets cancelled, x3 value is 3 lambda by 2. Are you able to understand? The position of nodes are at x equal to 0, then x equal to lambda by 2, then lambda, then 3 lambda by 2. If I make it, it will be something like this. Show you what are the nodes here. Okay, these are nodes. This node, you can say x equal to 0, this one, x equal to lambda by 2, this one, x equal to lambda, and this one, x equal to 3 lambda by 2. Okay, this is how we can find the positions of nodes for this standing wave. Exactly same way, we will try to find the position of antinodes for the same wave. Okay, now what are antinodes? Antinodes are the point where we will have maximum amplitude. This is antinode. This point here is antinode. This point here is antinode. And this point here is antinode. Okay, again, amplitude of standing wave is this. So this time I am going to write that when 2a sin kx, which is the amplitude of standing wave, becomes plus or minus 2a, those positions are called antinode. Why plus minus 2a? Because here you can see that this displacement is plus 2a, whereas this is minus 2a. So that's why I have written here plus minus 2a. Now this 2a and 2a gets cancelled, so we are getting sin kx plus or minus 1. Okay, so what value will be there for kx then? What will be the angle value? Now, kx can be pi by 2 because sin pi by 2 is plus 1. 3 pi by 2. 3 pi by 2 means sine of 270 degrees. 270 degrees means minus 1. Sine 270 means minus 1. Then after 3 pi by 2 what you can do? After 3 pi by 2 again it will be pi plus pi by 2 pi plus pi by 2. So 2 pi plus pi by 2 will be what? We can say 5 pi by 2. Okay, and likewise. So let's see what are their positions then. So kx equal to pi by 2 to start with. Kx equal to pi by 2. K value 2 pi by lambda into x equal to pi by 2. Pi gets cancelled. X value lambda by 4. So first antinode is at what position? Lambda by 4. This is lambda by 4. Okay, second antinode, what is the angle value? 3 pi by 2. Let's put it. Kx1 equal to 3 pi by 2. Put the value of k, 2 pi by lambda, x1 equal to 3 pi by 2. The x1 value is what? You can see that is 3 lambda by 4. Okay, where is this? It's here. Okay, so this is 3 lambda by 4. This value is 3 lambda by 4. Same way, the third one, this one, you can see that here is 5 pi by 2. That means this value will become 5 lambda by 4 from here. So this way we can find the positions of node and antinode for a standing wave. Is that okay? Alright, so now let us solve one question. A very simple question we are going to solve. The question is, find the minimum separation between 2 points having amplitude A in a standing wave, y equal to 2a sin kx cos omega t. Okay, we have to find the minimum separation between 2 points having amplitude A in a standing wave 2a sin kx cos omega t. So first let's make this wave. Okay, this is a wave. And what is the maximum amplitude here? 2a. You can see that if this represents the amplitude of standing wave, what is the maximum possible value of this? When this will become 1. So it's 2a. So this is 2a. Okay, and what the question is asking? A. So let's say A is somewhere here. Here also amplitude is A. 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 Here also amplitude is A, and here also amplitude is A. So what are we going to do here? First of all, we are going to find the separation between these 2 points. Let's say this point is P, this point is Q. Then I will try to find the difference between Q and R also. I am expecting R and S separation will be same as PQ. And here also, if I say this is T and U, then the difference between S and T will be same as Q and R, and difference between T and U will be same as R and S. Okay, so only 2 things I am going to find over here: the separation between PQ and separation between QR. Okay, so let's see now. Question says that 2 points where the amplitude is A, we have to find their positions. Okay, so what we'll do, we are going to equate 2a sin kx with plus or minus a actually. Do it for plus a. First let's find out between these 2 separation. Okay, this and this gets cancelled. It says sin kx equal to 1 by 2. Okay, so sin kx equal to 1 by 2. That means what is kx value? Now sin theta equal to 1 by 2. That means theta will be 30 degrees for sure first. So kx possible value pi by 6. Second value, second where it can be, I guess it's 150 degrees. 150 means is sine of 90 plus 60, which will become cos 60, which will be half. Okay, so sine 150 degree is also half. So 150 degree I have to write over here. So 150 degree we can write as 5 pi by 6. Okay, so pi by 6 represents point P, 5 pi by 6 represents point Q. We have to find the position difference between them. Okay, let's see then. This k value is 2 pi by lambda into x1 equal to pi by 6. Pi gets cancelled. X1 value I got is lambda by 12. Okay, let's see the next one for 5 pi by 6. Then kx2 equal to 5 pi by 6. So 2 pi by lambda into x2 equal to 5 pi by 6. Pi gets cancelled. X2 value we are getting is 5 lambda by 12. So what is the difference between x2 and x1? Can you see? It's 5 lambda by 12 and lambda by 12. The difference is 4 lambda by 12. That means lambda by 3. Okay, now what is left? We have to find position of R. And for position of R, I have to write this plus A as minus A. Then this value will become minus 1 by 2. So if this is minus 1 by 2, then what will be kx value? Kx value will become 210 degrees. Okay, it will become 210 degrees, third quadrant. Now this was in first quadrant, this position here. This you got 5 pi by 6, that's second quadrant. So definitely this is third quadrant. Okay, so third quadrant means 210 degrees. 210 degrees means 7 pi by 6. Okay, so see now, this is 7 pi by 6. So 2 pi by lambda into x3 equal to 7 pi by 6. Pi gets cancelled here. You are getting x3 as 7 lambda by 12. Okay, now we already found what is x2 minus x1. Okay, x2 minus x1, when we did 5 lambda by 12 minus lambda by 12, 4 lambda by 12, that is lambda by 3. Now we have to find difference between x3 and x2. So this is x3, 7 lambda by 12, x2 is 5 lambda by 12, that is 2 lambda by 12. So this position is lambda by 6. Now you have to find where it's minimum. Find the minimum separation between 2 points having amplitude A. So is lambda by 6 less or lambda by 3? Lambda by 6 is less. Okay, so two particles which are having amplitude A, what is the minimum separation between them? Lambda by 6. I hope it's clear to you. Okay, let's solve another question. Okay, the next question I am writing. If a standing wave is given as 0.4 sine 0.5x cos 30t, okay, then the question number 1, find the frequency, amplitude and wave speed of component waves, okay. And the second question, what is particle velocity? Particle velocity at x equal to 2.4 centimeter and t equal to 0.8 seconds. Okay, this is the question. This is what the standing wave is given to you. Okay, so first you try and solve it. Okay, now see what is the solution of that. This is standing wave. First thing is we have to do is we have to write what are these component waves. Two component waves. Okay, so what we can do, as I told you already, we can write this y as y1 plus y2. You can see the form is sine cos. Sine cos means is it is sine c plus sine d. So it means what? We will be writing this as 0.2 sine 0.5x plus 30t plus 0.2 sine 0.5x minus 30. Kx plus omega t, kx minus omega t. Okay, a sine of kx plus omega t plus a sine of kx minus omega t. Okay, what is a over here? 0.2, 0.2. This is two-way. Remember that in standing wave, whenever the two waves which have same amplitude of a, they are getting interference. Okay, so when they are in same phase, their amplitude becomes a1 plus a2, that is two-way. Okay, so these are these component waves. Now what the question is asking, find the frequency, amplitude and wave speed. Now amplitude you can see is 0.2. Here also 0.2, here also 0.2. So both have same amplitude 0.2. Frequency. Now we know that omega is given 30. So omega means 2 pi into frequency. So frequency is 15 by pi hertz. Okay, 15 by pi hertz. Then frequency you got, amplitude you got, then wave speed. Now wave speed means what? Wave speed means omega by k. Omega is given 30 and k value is 0.5. 0.5 means 1 by 2. So it becomes 60 centimeter per second. Okay, that's first question. Now let's go on to the second question. Okay. What is particle velocity at x equal to 2.4 centimeter and t equal to 0.8 centimeter? Now in this equation of standing wave, where is the position of the particle? Okay, and what is the direction in which particle is moving? That is very important for us to know. Otherwise we can get confused because x is also here, y is also here. So if you are talking about a particle, in standing wave, particle is moving like this. If we are talking about transverse waves, it's going up and down. Okay, so motion of the particle is happening along y-axis or x-axis? Answer is y. So y is given over here. So when we talk about velocity of particle, it has to be dy by dt. So what we will do? We are going to differentiate that to get the velocity of the particle. So velocity of particle here is dy by dt. Okay, so 0.4 sine 0.5x. Now this all becomes constant. Okay, because we are talking about a particular particle which is moving on along x-axis. So along y-axis. So its position along x is constant. Okay. Then differentiation of cos 30t. And differentiation of cos is minus sine 30t into 30. Okay. Now put the value. It's given the value 2.4 centimeter in time. So let's put it 0.4 sine 0.5. So 0.5 means half. X value 2.4 centimeter. Then minus, okay, minus is here, minus sine 30t, t is 0.8 into 30. Okay, what we are getting? 0.4 sine, what we are getting over here? 2.4 by 2, 1.2. Okay, and minus you can put over here sine. Now 30 into 0.8. 30 into 0.8 means is 24 into 30. Okay, this will be the velocity of the particle. Okay, this is velocity of the particle. I hope it's clear to you. Okay, let's go on to the next question now.